Okay, welcome back. In this lecture, we're going to start with hypothesis testing. Previously, we looked at estimation, which is another form of statistical inference. We looked at point estimation and interval estimation. But now we're going to look at hypothesis testing, which is also a form of statistical inference. Now, hypothesis testing is where we make a certain statement or a claim. And then we gather some information in the form of, typically in the form of a sample, and we use that to help us decide whether the statement is true or false. I'm going to explain the concepts of hypothesis testing by making use of an example that people will be familiar with. So let's say that a person is accused of a crime and this person faces a trial. Now, the judge must, based on the evidence, decide whether the defendant is innocent or guilty. We have two hypotheses. The null hypothesis, which we indicate with H subscript 0, is that the defendant is innocent. The alternative hypothesis, which we indicate with H subscript 1 or sometimes H subscript A for alternative, is that the defendant is guilty. Of course, the judge does not know which of these two hypotheses is correct. And the judge has only two possibilities in his or her decision, either to acquit or to convict this defendant. And the judge must now make use of the evidence available to make this decision to either acquit or to convict. So to convict the defendant is to reject the null hypothesis of innocence in favor of the alternative of guilty. To acquit the defendant is to not reject the null hypothesis, to not reject the hypothesis of innocence. Just note here that we do not say that we accept the null hypothesis. So we do not say that we accept that the defendant is innocent. It is just that the evidence against the defendant is not sufficient to come to the conclusion that the defendant is guilty. So the defendant is found guilty only if the evidence against the defendant is beyond reasonable doubt. So we can think of it in this way. We have the true state of affairs, which is unknown to the judge or to us. And then we have to make a decision based on some evidence. So the true state of affairs can be when the null hypothesis is true. For our example, that would mean that the defendant is in fact innocent. And we have the alternative hypothesis, which is that the defendant is guilty. Now, if the judge, based on the evidence, decide to not reject the null hypothesis of innocence, and the true state of affairs is in fact that the defendant is innocent, then we are making the correct decision. However, if the defendant is in fact innocent, if that is the true state of affairs, and the judge convicts the defendant, then he is making the wrong decision, and we call that a type 1 error. Now, this is a serious mistake or a serious error to make in this situation because you don't want to convict an innocent person. So we would like this error to be as small as possible. Now, on the other hand, we can have that the alternative is true, in other words, that the defendant is guilty. If the judge do not reject the null hypothesis of innocence when the defendant is in fact guilty, then the judge is making an error, and we call that the type 2 error. If the defendant is guilty, in other words, if the alternative is true, and the judge rejects the null hypothesis of innocence, then the judge is making the correct decision. So we would like these two errors, the type 1 and the type 2 error, to be as small as possible. Now you will hear the term level of significance very often when you do statistical hypothesis testing. The level of significance, the explanation of that is the maximum probability to make a type 1 error. Now, we would like the type 1 error to be as small as possible, and the typical levels of significance are usually 5% or 1% or 10%, depending on the situation. For example, in this case, where we do not want to convict an innocent person, we would like the type 1 error to be as small as possible. Now, on the other side, we also don't want to acquit a guilty person, so we would also like the type 2 error to be as small as possible. Just note, however, that the probability of a type 2 error, which we indicate with beta, that probability and the level of significance, or the probability of a type 1 error, which is indicated by alpha, those two errors are inversely related. That just means that for the same amount of evidence or for the same sample size, if you decrease alpha, your probability for a type 1 error, you will increase your probability for a type 2 error. And if you decrease the probability for a type 2 error, the probability for a type 1 error will increase. Okay, so the important concepts are that we have two hypotheses, the null hypothesis and the alternative hypothesis, which is also sometimes called the research hypothesis. In the testing procedure, we start out by assuming that the null hypothesis is true. So we start out by assuming that a defendant is innocent. And then we determine whether the evidence is sufficient to infer that the alternative hypothesis is true. So is there enough evidence to say that the defendant is in fact guilty? So we have two decisions: to either reject the null hypothesis in favor of the alternative, or to not reject the null hypothesis. And because we have to decide and we do not know the true state of affairs, we can also make the wrong decisions. And we have two types of errors: the type 1 error, where we wrongly reject the null hypothesis, and the type 2 error, where we do not reject the null hypothesis when in fact the alternative is true. So the type 1 error is when we convict an innocent person, and the type 2 error is when we acquit a guilty person.